LeetCode Problem 230, kth smallest element in a binary search tree. So this problem gives us a binary search tree and an integer k, which will have to return the kth smallest value of all the values of the nodes in the tree. So what does that mean? So looking at this binary search tree, so in the binary search tree there is 1, 2, 3, and 4. And since k is 1, we will have to return the first one, right? So if let's say this was 2, 1, okay, let's say this was 3, which is technically the same thing. Let's say this is 6, 6, 2, 4, 10, for example. So our list will be 2, 4, 6, and 10, and k is 3. We have to return 6, right? Okay, so another example, let's say this one. So inside the list we have 1, 2, 3, 4, 5, and 6. Now the values are in ascending order with a difference of 1. This is by coincidence, where if it was any other values in this particular sorted order, we still have to return the kth one. So this is 1, 2, 3, right? So we still have to return the kth value lah. So this could be 6, so we have to return 6, something like that. Okay, that's what he meant by the kth value. Okay, so one way to approach this problem is to traverse through every single node, and then like what I just did, and then putting it all in a list like this, right? You can have a vector or a list or something that stores all the nodes value, and then once you're done, you can just return the index version, right? So let's say if k is equals to 1, you can just return the index version of this, right? But this is not how I approach this problem. This is not how I approach this problem. The way I did it was I traversed to the most left node, in this case it will be 1, and I have a counter, and let's say this counter is 0, and k, which is 2. So when I reach the most left node, my counter will increment, right, 1, and then I try to go to the right, which is 2, my counter will increase, 2, and when the counter and k are the same, I will return 2. Now let's say if k were to be 3, and since I recursed from here, so I have to go back here, and when I'm at 3, counter will increment to 3, so and here I'll return this node instead. Okay, so let's show you the code. So like I mentioned, I'll be using a depth search DFS. Before that, I have a counter which starts at 0, and this red is the return. This is what we are going to be returning. Both counter and red are referenced, so we just have a copy, and then we have k for the k value over here, and the root, so starting at the root. So I'm going to put the count over here in the red, separated by a line, and here will be our recursive function. So root is 3, right? We're starting at 3 first, and instead of 1, let's do I don't know, like 4. Okay, let's do 4. So root is 3, k is 4. Okay, so DFS to the left, DFS to the left, right? DFS to the left. Again, root count red. So root is 3, k is 4. At this DFS, I'm actually at this node now, right? Okay, and then when I DFS again, this is actually a null node, right? There's no nodes here, so this is a null. So let's put null here. indicating that it has returned. Once I'm done with that, my count increments, like I mentioned, so count is now 1. If count is equals to k, in this case it's not, k is 4, right? So actually k I can put here also. It's gonna be the same anyways. So count is not equals to k, so what we do, we try to go to the right side. Go to the right side is equal to 2. So we DFS again to the right side. Now the root is 2. Right, so 2. Okay. Count increments one more time. 2. Count is not equals to k, and our right will now close. This will close. Our left has finished running. Finish running here. So now our count will increment again. Go here. Now we're back at the base. We're back at the base node. Right, we're back at the base node here. So let me clear everything. So we're back at the base node here. And in this case, if count were to be 3, like I mentioned just now earlier with my example, we will have to return the root value, which is in this case 3, but in this case it's not. So we DFS to the right this time. Okay, so here we DFS to the right. Okay, sorry, just now I don't think I should have done what I just did. Okay, when I DFS to the right over here, at this node, right, I will need to actually no, nothing happened. Yeah, because I just returned. I don't need to increment count again. Okay, never mind, let's continue. So DFS on the right. So now we're going to right side. Over here 4. So the root is now 4. The root is now 4. We try to go to the left. Left is null. Right, because there's nothing over here. Nothing over here. So we increment count. So now count is 4, which is the same as k. Right, k is 4 as well. So red will become root value. So our red will now become 4. Right, because our root value is 4. So our red will become 4 as well. And then we DFS to right. No, we don't DFS to right. We return. When this returns, it will return back here, and it will just return the entire recursion back to where we came from, and return our red, which is 4. Okay, I'll give another example. Let's say for this one, okay, let's say for this one, 3, count is 0, red is 0, k is 3. Right, let's use 3. Okay, so we're starting off here, root is not null, so we go to the left again. I press left. Hey, sorry, root was not 3, root was 5. Then we are going to the left node. So here is 3. So root is now 3. It is not null, so we DFS again. Root is now 2. Right, we're going over here. Root is now 2. Not null. It's not null, so we DFS again. So now we're going to 1. Right. And since this 1 is not null, so we don't have to do anything here. And then we DFS left again, but in this case the DFS left returns us with null because there's nothing over here. We increment our count increment, and then we DFS our right, which also will give us null. Okay, once that is done, this root is done. So this should be left. So yeah, okay. So that was almost a bit confusing there. Okay, so once we are done with the left here, we increment our count again. Count is not equals to k, right? Okay, is 3, so we DFS to the right. Over here, but in the right node we give us null, right? Because over here the right node is null. So when that is done, we're done with this. So we exit here, increment count again. So now count is 3, which is the same as k. So now our ret will become our root's value. So if you look closely, in this block, the root value is 3. And then we return. We don't need to DFS. We return here. We return. So when we're done with the left. Okay, when we return here, left, it did not return immediately. Because here, what actually happens is that we will have to increment count again, even though we have already found our answer, right? So we increment count again and basically do the rest of it, but fear not, it will never reach k, because at this point count will always be more than k, right? So you just continue iterating through the nodes until we have finished iterating through everything, and then return our ret, which is 3. Okay, yeah, pretty sure I messed up a bit here as well, because it's the same thing. It will recursively traverse through all the nodes in the binary search tree, then only exit the DFS function, and then return our ret. Okay, hopefully that doesn't confuse you a lot. That's all I have to show. Thanks.